This is the next question, and I have taken this from an exam. This is going to serve a very important thing. I hope you can see that as well. Whenever you see a problem video uh, or a video with a problem being solved on it, always pause at the start and first have a look at it yourself, and then follow with my explanation. So if you look at this problem, here we have to find the voltage across the switch. Obviously, the switch was initially closed. So if a closed switch is going to have uh, voltage of zero because it's a short circuit, but when it opens up, the voltage across it would not be zero. It will be basically because of the two circuits on each side, and we have to come up with an expression for it after being opening up. Now in this question, if you look at the question, when the circuit is in steady state before t is equal to 0, and remember before t is equal to 0, this is 0 because of this ut, remember the unit step function. So this is 0 before t is equal to 0, so it's shorted out. 0 means it's shorted out, and this is shorted out, this is open, so no current flowing here. So what will be the voltage across this one? Obviously 0, and this will be shorted out, all energy drained. So there is nothing in this circuit before t is equal to 0. Everything is 0, no state. And after t is equal to 0, just when the switch has been opened, because there was no energy initially in the circuit, this shorted out, this opened up, and this resistor in there, no voltage across this, no current through this, no current through this. So there will be no voltage initially across this, and no current initially through this. However, similarly in this circuit, there will be no current here, so no current would be after switch has been opened here as well. Now, if you look at this circuit, when this was um, opened, there was no initial current here. So at t is equal to 0 plus, there will be no current as well. So no current, nothing flowing in here. So the voltage across this resistor would be 0. So it would be here 0 as well, and 0 here as well. So voltage across this 0. So if we take this as a reference node, then this would be as at 0 volts as well. If this is 0 volts, this would be at 0 volt because no voltage across this. So whatever the voltage is across this switch will be the voltage across this resistor. So basically this question says find the voltage across this resistor, which is the same as that voltage across which. And see, the inclusion of this thing hasn't changed anything. So you can replace all this by a short. So basically it is just a switch across this resistor. So if you pay close attention, the circuit may simplify. And now comes the interesting part. So if we have to find this Vs in this circuit, now this voltage source of 5 volt has come into action as well. So for t greater than 0, the voltage source is 5 volts now. We have a capacitor that has an initial voltage of 0. We have an inductor that has an initial current of 0. And we have to find this voltage V as T across the 2 kilo ohm resistor. The interesting part is, pause here and try to find what I am going to say. What is the interesting thing in here? The interesting thing in here is we have not seen this circuit. It is not an RL or RC circuit. Although I copied this in my preparation for this session, but I now realize it is not a circuit of RL and RC, but I decided to include it in here so that when I say to you that in solving a problem, you should always write things that make sense. So when you logically come to this point, all our discussion had been logical till this point. So after this, no sane person with the knowledge of RL and RC circuits only can say, I know the solution. Don't say that uh, uh, the final value of Vs and Vst would be equal to the final value of Vs plus the initial value of Vs minus the final value of Vs e raised power minus t over tau. Don't say this. What will be tau here? What will be tau here? Do we know how to solve it? No, because this is not an RC circuit or an R circuit. All three are components are there in this circuit. So this is an RLC circuit which we have not studied till now. This is the topic of the next chapter. Once we have solved that, come back and solve this again. So it is very simple RLC circuit with the zero state and finding its force response. So when we do that, and it wouldn't be something like this. There may be this involved, finding the final value. So in final value, by the way, we can find it here as well. So can you find what will be Vs infinity here? Yes, because in steady state, this is going to short out. This is going to open up because this is a constant voltage source. So this steady state behavior will happen. And all this voltage is going to appear here. So Vs final value is 5 volts. What is the initial value of Vs? So it was shorted out. So sorry, it had zero current through it because before switching there was zero current flowing in here. So right after switching there would be zero current here, and there will be zero current in the whole circuit because everything is in series. So zero current here, zero current here. So Vs would be 0 volts. So we know these things, and we may use them in the solution when we are going to solve it in the next circuit, next chapter, RLC circuits. But this term is definitely going to be replaced because it's not going to make sense here. In an RLC circuit, the tau is not obvious here. So we need to know more about this circuit. We are going to do that later on.